Hello everyone, my name is Silas. Welcome to our fourth lesson in flight dynamics and control. Last time we saw how to go ahead and derive some equations of motion for a system of springs using summing the forces and summing the moments. So today we're going to go ahead and figure out what actually to do with these equations. So right now I just have a equation written down. It's a second order differential equation with a forcing function and cosine of t. So we'll just go ahead and go step by step on how to solve it. I'll already assume that you've done a little bit of differential equations before in your life. If not, I'd go ahead and review how to do them. This is a second order linear differential equation if you're wanting to look up how to do it. Otherwise, we'll just get started right now. So, first step we do is we take the coefficients of these front of the x terms. So we have a 1, -2, and a 2. So we'll just put those coefficients in front of these this equation with lambdas. So we'll have lambda squared. This will get the coefficient of 1. We'll have a minus 2 lambda. That'll get the coefficient of the -2. And then we'll have a plus 2. Notice that these lambdas are going in decreasing power. We want to find lambda such that this equation equals 0. This is just a quadratic equation, so we'll just go ahead and solve it. The easiest way to solve it is just a quadratic formula. It's always right, and in this case, it's the easiest. So the other options is if you could factor it, you could go ahead and do that. This isn't too easy to factor. I mean, you could do it by completing the square. That's another way, but quadratic formula will work in this case. So we know that, not x, lambda equals negative this term, the middle term, negative b, and negative 2 will be positive 2. So we'll have a positive 2 plus or minus the square root of this middle b term squared. So that'll be 4. And we'll subtract 4 times this coefficient a times this coefficient c. So we have minus 4ac. So that's times 1 times 2. This whole thing is going to go over 2 times this first coefficient, 2 times a. So let's just go ahead and simplify what this is. We have 2 terms in the top over 2, so we'll just go ahead and split it up. So we have 2 over 2 is 1 for our first term. Now our second term is the square root of 4 minus 8. That will be -2, the square root of, or not -2, -4. So the square root of -4 is 2 times I. So 2i over 2 is 1, or just I. Or yeah, 1i. So we have a plus or minus I. So that is what our lambda is. So in differential equations, if you've done this type before, you know what to do. You just assume the answer is something in the form of some constant e to the something t power. We'll go ahead and do the same. So we'll just assume that the solution looks like this. So assume that it's equal to a, or at least this part of the solution. It's not the part with not the particular part. So we'll just assume that this is equal to some constant. We'll call it a1, e to this lambda times t. So it'll be 1 plus I times t, and then this next part will be b times e to the other term right there because it has 2 roots. So it'll be 1 minus I times t. There we go. We have our solution right there. Now this is not a very pretty form because it has these imaginary numbers in there. So the next step, if you've done these before and you realize when there's a negative root, there's a formula of what you do, but we'll go ahead and just kind of walk through what to do when we get these i's. So to start off, we'll just recall what Euler's formula is. So his formula, it says that e to the something, we'll just call it theta. This term is equal to cosine of theta minus sine theta. This is j sine theta. Okay, and then similarly for the negative, we have e to the negative j theta equals cosine, that's plus right there, cosine theta minus j sine theta. So using these two identities right there, or two formulas or whatever you want to call them, we can go ahead and plug them into this part right here. Because remember, we can always split up these e powers. So we can split it up into, we'll just substitute this t in, so that's e to the t times e to the I. Remember, we can split when it's a sum of this, or it. When it's a sum, we can always split it up. So now we have b e to the t times e to the it. So we want to go ahead and take these two terms right here. It's a minus, my bad. We want to take these two terms and put them into this form right here. So we will end up getting x is equal to a1 e to the t times cosine theta, which our theta in this term, it'll just be t, times, or I'm not, excuse me, plus j sine t. And then similarly for the b term, or for this next term, we have b e to the t times this guy, whatever this guy will be. In this case, it will be cosine t minus j sine t. Now, next step, what we want to do is we want to combine the cosine terms with, and then we want to combine the sine terms as well. So we can write is that this is equal to a1 plus, or I guess, oh, that's weird. Why I called them like that? I guess we'll keep with it. So a1 plus b times e to the t times cosine t. Then this next term will end up being, we'll add it, so a1 minus b e to the t times sine t, j sine t. So there we go. We can always go ahead and rename the a plus b and the a1 minus b, because remember, they're just constants. We can go ahead and rename this. Well, I want to name this one a, and I really wanted to name that one b, so I guess we can go ahead and let's just give these ones b's for their names. So b1, we'll just rename this one to b. So we have our new constants, a and b. That's all they are. So this is starting to look a lot similar, or if you've ever done these before, this looks like they're supposed to look like. So once we got this form right there, we'll just go ahead and rewrite that. We have x equals a e to the t cosine t plus b e to the t j sine t. That looks sloppy. B e to the t j sine times t. Okay, so there we go. We have that part. Now, what we need to do is we need to find, we have this cosine function right here. So we need to go ahead and find that particular part of the solution. So to find the particular part of the solution, we just assume that it's going to be in the form of, let's just say, c cosine t plus d sine t. So we'll just assume the x, whatever particular part we'll call it, to assume that it's going to be equal to something like this. That's our assumption. So all we got to do is we just got to plug it in. The way to find it is we just plug it into this equation and figure out what it will be. So in order to do that, we have this x double dot, x dot, and regular x. We just have this y, or x, so now we need to find the derivative of that. So we need to find x dot. That is going to be equal to, derivative of cosine is negative sine, so that'll be negative c sine of t, plus the derivative of cosine is, or sine is cosine, so that's just d cosine t. This one's pretty easy. They can get a lot harder than this, believe me. Next we have our double dot, and that's simply going to give us negative c cosine t plus d sine t. That's a negative. So there we go. Now we just need to go ahead and plug these guys back into this original equation of x double dot minus 2x plus x equals cosine t. So we'll go ahead and plug these in. So we'll do our double dot first. It has a coefficient of 1, so we can just go ahead and write the equation down. So we will have, we'll move that up, we will have negative c cosine t minus d sine t. Now, our next part, we have a negative 2 for our coefficients. So we'll go to our x dot term. We have a negative c sine t plus a d cosine t, and it's all getting multiplied by negative 2t. So then we will end up with a negative 2 times negative c is just 2c sine t. So we'll have 2c sine of t, and then negative 2 times d is going to be negative 2d, and that's a cosine t. So it'll be 2d cosine t. And then finally, we have our regular x term that's going to be multiplied by a coefficient of 2. So we will just have plus 2c cosine t plus 2d sine t. Hope you can see all that right there. And then all this is equal to, it's equal to cosine t. So what we want to do is we want to combine all of our cosine terms and our sine terms together in two different rows. So I'll just go ahead and start separating them out. So for our cosine row, for our cosine of t, we have a negative c. Let's see, going across, now we have a minus 2d. Going across some more, we have a plus 2c. Okay, now let's do our sine. Oh, actually, we forgot that's equal to this just 1. That has to equal 1 because we have, this is our cosine terms. Now for our sine terms, oh, let's move that over. Sorry about that. So our sine of t terms, we have a negative d. Moving over, we have a plus 2c. And let's keep moving over, we have a 2d. And that is equal to, we have no no sine terms, so that must be equal to 0. Now, there we go, let's go combine these terms together. So we'll have a, let's just move that over, that's going to be equal to c minus 2d. If we combine them, that's equal to 1, and then we're going to combine these two d terms together. Let's keep the c in the right position, so that'll be 2c plus d. And that is equal, there we go. So now let's just turn these guys into a matrix form right over there. So we will have 1, negative 2, 2, 1 times c times this matrix, and that has to be equal to 1, 0. So we just want to solve for c and d. The easiest way to do that is just to type it in on your calculator using the reduced row echelon form or any other method you can think to solve it. I personally just like to use the reduced row echelon because it's just plug and chug, and it's pretty easy to do. So if we do that, won't bore you with the arithmetic on that. Turns out we get, oh, what was it? Turns out we get 1/5, or c equals 1/5, and b, or d equals negative 2/5. So there we go, that's what c and d are. So let's go on to the next page, and then we'll just go ahead and rate our final solution, or mostly final solution. So we have x equals a, or what was it? What did I write there? A et cosine t plus b et sine t. There we go, and then we add our other solution that we're assuming the solution of. That's tongue twister right there. So we have plus c, or it'll be equal, I'll just write them out first. We have cosine t plus sine t. This is our assumed solution. They have the they have coefficients that we just solved for, c and d. So we'll go ahead. Let's see which one is what. So we're assuming that c cosine t plus d sine t. So the c corresponds to the cosine. So that c corresponds to the cosine. That d corresponds to the sine. So I'll just go ahead and add those coefficients there. So we have 1/5 cosine t. And then for our sine, we have negative 2/5. There we go. We're almost done. I'll just go ahead and rewrite our initial conditions that were given several minutes ago. So we know that x of 0 is equal to 1, and then we know that x dot of 0 is equal to 0. There we go. Now, we'll go ahead and plug it in. So x of 0, this is the easy one, x of 0 is 1. So we have 1 is equal to, let's see, cosine of 0 is 1, cosine, or e to the 0th power is 1, so therefore we get a. Now b term, so sine of 0 is 0, so that whole thing goes away. Cosine of t, or cosine of 0 is 1, so that'll be a fifth. And then the sine term right here, it just kind of goes away when we plug in 0. So, therefore, we know that a equals 4/5. There we go. That's one of them. Now the second one we need to do is take the derivative, because remember we have x dot of 0 is 0. So now we need to go ahead and find what the derivative of that is. So let's go ahead and find the derivative. So x dot equals, we know that e to the when we take the derivative of e to the, it's always going to be e to the whatever power. So when we take the first one is when we'll take, let's just pull this coefficient out first. So we have a times e to the, we'll leave this one alone and take the derivative of that one. So e to the t, derivative of cosine is negative sine. Now we have to add the other one, so we'll leave this one alone and take the derivative of that, which is still e to the t times cosine t. Do that for the next term I should say. So we have b e to the t, oops, we'll do that, e to the t, and then now take the derivative of that, we get cosine of t plus e to the t derivative, and leave that alone, so we have sine of t. And let's go ahead and do it for the other two terms. Now we have that in the center. Now the derivative of cosine is negative sine, so we have minus 1/5 sine t. Now the derivative of sine is cosine, so now we have plus negative 2/5 cosine t. There we go. Now we have our full derivative right there. Let's go ahead and plug everything in. So we know that it has to be equal to 0. That's equal to, let's plug in 0. So when we plug in 0 in this term, e to the t, that's going to be 1. When we plug in t equals 0 into sine, that goes away. Likewise, when we plug in 0 into cosine, that turns into 1. That turns into 1 right there. So we'll get a for that whole term. Now for this term, same thing. We have cosine of 0 is 0, or sine of 0 is 0, so that whole term goes away. Cosine of 0 is 1, e to the 0 power is 1, so now we get b as well. There we go. Now simplifying pretty quickly. So now we have these two terms. This sine of t is going to go away because sine of 0 is 0. Now this cosine of 0 is 1, so we get minus 2/5. There we go. Now let's plug in what we found out for a. So we knew that a is 4/5, so let's rewrite this. We know that 0 equals 4/5 minus 2/5 or plus b. So let's just solve for b real quick. That's pretty easy. So let's subtract those. We get 2/5 and move it to the other side. That's negative 2/5. So we know that b equals negative 2/5. So there we go. Now finally let's just rewrite the whole thing right now for our final answer for the final time. So x equals a, which we found out was 4/5, e to the t cosine t plus b, which is negative 2/5, e to the t sine t plus 1/5 cosine t. So we have that so far. And then finally, minus 2/5 sine t. So that right there, ladies and gentlemen, is the solution to that differential equation with that forcing function of cosine of t. Next, we're going to actually go ahead and look at how to do this in an easier way. So I hope you understand where we're going here. Next, we're actually be doing, next we'll actually be taking the Laplace approach to that. And you'll find that it makes things a lot easier because you don't want to be doing this every single time because it's tedious and it takes a while. So we'll just do that in just a minute or next time.